In this video, we are going to see the next question related to proof. That means it is also a property and also a question which is related to tangent inverse of x. The formula goes such that tan inverse x plus tan inverse y. Prove tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, and the condition on xy is given to me as xy less than 1. Now, there will be three formulas related to tan inverse, and this one is the first formula in consideration. We will learn the proof of this formula, although it is not actually explicitly mentioned in the syllabus. But for those people who want to know some extra facts, I am giving the proof as well. And after this video, we will be having the next video for the second formula based on tan inverse x plus tan inverse y, where the condition for xy will be different, and similarly we will have a third formula for the third video. Let's get started with the formula number 1. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, wherein the condition for xy is given to me as less than 1. Right? Now, for proving these type of questions, we need to assume some things. I mean, if I have two terms which are added up together and I have a formula in tan or tan inverse, I know that tan A plus B is what? It is tan A plus tan B upon 1 minus tan A tan B. So, I will use my knowledge of tan A plus B, which I already know from my junior class 11th, that yes, if tan formula I know, I can use it in a manner to at least have some knowledge about tan inverse x plus tan inverse y. So, let's get started, and then we will see what things do we need extra and what things do not need. Just write the formulas. So, I assume the first thing as what? I have two terms, tan inverse x and tan inverse y. So, if tan inverse x is A, tan inverse y is B, some things can be directly put. What things? Let's see. So, I write the proof as let tan inverse x is A, tan inverse y is B. Let tan inverse x is A, tan inverse y is B. That means I have the two terms as substituted for A and B. If this happens, then I know that what is the value of x? What is x? X is here, tan inverse goes there, becomes tan, it is tan A. And what is y? It is tan B. Right? Now, what is tan A plus B? We know the formula from our junior classes. It is tan A plus tan B upon 1 minus tan A tan B. Now, if these values are to be put from the formula, since it is a formula, I am writing it in a box so that you understand it very much easily, that yes, it is a formula. What is tan A? Tan A is x. What is tan B? Tan B is y. So, I substitute x plus y upon 1 minus xy. For what? For tan A plus B. Till here I have done. Let me repeat till here. I know that I have tan inverse x is equal to A, tan inverse y is equal to B, and then by assuming these things, I just put it in the formula. I got tan A plus B is equal to tan A plus tan B upon 1 minus tan A tan B. So, it became x plus y upon 1 minus xy. Now, condition on xy is given to me. Condition on xy is given to me as what? That I have xy less than 1. If xy is less than 1, what cases can we assume? We can assume the first case, that yes, both x and y are what? Either both have one thing, that one is negative, one is positive. Why? Because xy, if less than 1, that means one negative, one positive will give me less than 1. Or one more thing is there, that they are fractional values. Say 1 by 2, 1 by 3, so it becomes 1 by 6, again less than 1. So, xy less than 1 can have three cases. When in the first case I can take x greater than 0 and y greater than 0 only. Case 1, x greater than 0, y greater than 0, both greater than 0. That means both are not in the condition of negativity, but yes, they are less than 1. They are less than 1 means they are fractional values, and 1 by 2 into 1 by 3 will give me 1 by 6 or something of that sort, which will be less than 1. So that means my first case number 1 is what? Case number 1 is very much simple. I assumed case 1, I will write here. What is the case 1? That yes, x and y both are greater than 0, but my xy is less than 1. If this is the case that x and y are both greater than 0 and xy less than 1, what is the condition for x plus y upon 1 minus xy? X plus y, although greater than 0, not less than 1 or less than 1, we don't need to consider. Both are greater than 0, so their addition is what? Their addition is also positive. And 1 minus xy, if this is negative, I have all these things computed together and my numerator upon denominator value is what? Something put in negative, 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 positive, 1 plus positive is positive, numerator is also positive, so everything is nothing but greater than 0, right? Now what is x plus y upon 1 minus xy? X plus y upon 1 minus xy is tan a plus b, so that means my tan a plus b is what? Greater than 0. Now if tan a plus b is greater than 0, which I write here, that means the tangent of some angle is positive. So tan is positive in which quadrant? First quadrant or third quadrant. So first quadrant or third quadrant will give me positive tan. So I just write it here as a plus b in which quadrant? Either first or third quadrant. Why? Because I know that positive tan is only in first or third quadrant. Suppose it is in first quadrant, I have a plus b angle in the first quadrant. That means 0 to pi by 2 will be the criterion for the first quadrant. Now 0 to pi by 2 is my a plus b. That means tan a plus b is what? It is positive. So tan a plus b is equal to x plus y upon 1 minus xy, which is the formula. I wrote it from here. That also means what? If I want to keep this tan to the other side, it becomes a plus b is equal to tan inverse x plus y upon 1 minus xy. That also means what? A is what? A is given to me as tan inverse x, b is given to me as tan inverse y. So it becomes tan inverse x plus tan inverse y. And the right hand side does not change, it remains the same, that is tan inverse x plus y upon 1 minus xy. So I put the result in the bracket. What is changed? Only this thing is changed, that yes, my cases would be different. My cases can be many. The first case that we considered was what? That my x and y are both greater than 0, both non-negative, but both multiplied give me less than 1, and I substituted tan inverse x is equal to a, tan inverse y is equal to b. The whole story was same. Here we arrived at one thing, that tan a plus b is greater than 0. That means a plus b is either in the first quadrant or in the third quadrant. So if in the first quadrant I have 0 to pi by 2 range, substituting the values, my final result is this. For which condition? For xy as less than 1. This was the case 1. The proof for case 1 is clear. Now the formula is such that I have xy less than 1, and for xy less than 1 my case 1 was x greater than 0, y greater than 0. Not only the proof is valid for this case, that means x and y greater than 0, but some other cases as well. So let's see the case 2 of the same formula of the same proof. Now let's see the case 2 of the same formula's proof. The things are similar in what respects? That yes, again I have tan inverse x is equal to a, tan inverse y is equal to b. So, x is equal to tan a, y is equal to tan b. Also, I will be applying the formula of tan a plus b, which is tan a plus tan b upon 1 minus tan a tan b, and tan a tan b values are put from the above cases, and then we have x plus y upon 1 minus xy. Now, the case 2 follows after the case 1. The proof for case 2 will involve again x and y. I know that xy is less than 1. So, my case that I am taking now is what? That yes, let x less than 0, let y less than 0, and let xy less than 1. Now, some of you might be thinking that if x is less than 0, y is less than 0, both are negative, and negative into negative is what? Negative into negative is positive. So, how it is less than 1? My dear students, consider that xy less than 1 is given and not less than 0. So, it again is a positive quantity greater than 0, but it is less than 1, right? So, now let us get started. X is less than 0, y is less than 0, x, y less than 1, not less than 0. I have, if these conditions given in front of me, what is the scenario and what is the position of x plus y upon 1 minus xy? Definitely x plus y less than 0, that means negative, and 1 minus xy, all these things when computed in the form of numerator and denominator, what will be sign of this quantity? The sign of this quantity will be always what? It will be always less than 0, because the numerators are less than 0, so minus sign will be there. So, that means x plus y upon 1 minus xy would be less than 0. Now, if x plus y upon 1 minus xy is less than 0, that means what? That means tan a plus b is less than 0. So, I write tan a plus b less than 0. If tan a plus b is less than 0, in which manner I can make 0 more beautiful? So, let us make a big 0, right? Tan a plus b, tan of something is negative, that means what? Tan is either in which quadrant? The angle is either in second or the fourth quadrant. So, I have my a plus b angle in which quadrant? In either second or fourth quadrant. So, either second or fourth quadrant. Now, suppose I assume any one of these, I take fourth quadrant for that manner. If fourth quadrant is taken, what is the thing? That I have x less than 0 for fourth quadrant, and also I have y less than 0 for fourth quadrant, or the second quadrant, any quadrant you can take. So, x is what? It is tan A, and y is what? It is tan B. So, they are related to what? They are related to A and B. So, I can write it down as x less than 0 means minus pi by 2 to 0, fourth quadrant I am taking. Y less than 0 again related to B for minus pi by 2 to 0. Now, if A explicitly is known to you, B individually explicitly is known to you, what is the scenario and behavior of A plus B? That also we can know. So, A plus B would be what? A plus B means minus pi by 2 and minus pi by 2 you add, it becomes minus pi. 0 and 0 you add, it becomes 0. So, minus pi to 0 is the scenario and the interval for A plus B. But we do not want A plus B. What do we want? We want tan inverse x plus tan inverse y. That means here, if A plus B is known to us and these things are related to x and y, we can easily go for tan inverse x plus y. So, let us see now. That means I have tan A plus B, which was x plus y upon 1 minus xy, as something now manipulated. How? My tan goes to the other side, it becomes tan inverse x plus y upon 1 minus xy, and the other side is left with only and only A plus B. Now, what is A? A is nothing but taken as tan inverse x. What is B? It is tan inverse y. So, A plus B is tan inverse x plus tan inverse y, and these things can be put in a box because this is the final result. So it is hence proved. So in this case, what did we see? That yes, similar to the first one, we assume the same things, but different is what? That I have taken x and y as both less than 0, but their product is what? It is less than 1. In the previous case, there was something different with x and y. There is a third case also, and with these three cases which you will prove, you will finally say from the case 1, from the case 2 and from the case 3. So these three cases will help me prove that yes, tan inverse x plus tan inverse y is equal to tan inverse x plus y. So let's see the case number 3. So now let's see the case 3. Case 3 for tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, wherein xy is less than 1. Now if xy is less than 1, we saw already two cases, and case 3 is also similar to the two cases wherein we do not change the above assumptions. I know that tan inverse x is equal to a. I have already assumed that tan inverse y is equal to b and x is equal to tan a, y is equal to tan b. But what else do we need to consider? As in the previous cases, I have xy as less than 1. This is what I need to consider. Now if xy is less than 1, we already have seen the previous two cases, but in the third case, that is in this case, I will assume, say, x less than 0, y greater than 0, and so xy is less than 1. That means x is negative, y is positive, both multiplied give me negative, and if give me negative, so yes, definitely it is less than 1. Or one more thing that I can take into consideration is x is greater than 0 but y is less than 0, and so xy is less than 1. That means x is positive, y is negative, both multiplied again negative, less than 1. So any of these two can be taken. Suppose I am taking the first criterion, that yes, I have x less than 0, y greater than 0, xy less than 1. If this is the case, x is less than 0. X is less than 0 means what? Tan inverse x is equal to a. This you need to take care. If x is less than 0 or y is greater than 0 or any of these things are there, I already know that tan is negative where? In the second quadrant and the fourth one. I already know that tan is positive where? In the first quadrant and the third one. So let's club these, take any of these conditions, right? Taking any of these conditions, I have a belongs to what? A belongs to 0 to pi by 2. And b, which is related to y, would lie in the second quadrant, say. So I have minus pi by 2 to 0. That is, I am taking the fourth quadrant here. Anything can be taken, right? If a belongs to 0 to pi by 2, b belongs to minus pi by 2 to 0, I need to add these up. So what is a plus b? A plus b, let's see here. A plus b belongs to what? A is first thing, b is second thing. 0 plus minus pi by 2 is minus pi by 2. What next? Pi by 2 here and 0 here. So pi by 2 plus 0 gives me pi by 2. So it lies from minus pi by 2 to pi by 2. Now again I have the same things, a plus b, range and interval is already found out. And I have one thing already known to me, that yes, tan a plus b is equal to x plus y upon 1 minus xy. From where do I know the tan a plus b formula? From this step and this step explicitly. So these things go here. I have tan a plus b is equal to x plus y upon 1 minus xy. Now, x plus y upon 1 minus xy is known to me. If I have tan here, want to bring it to the other side, what happens? It becomes tan inverse x plus y upon 1 minus xy is equal to a plus b. Now what is a? A is nothing but as tan inverse x. What is b? B is tan inverse y. You just substitute the values. Tan inverse x plus tan inverse y. And these things put in a big box because I have already proved, and this was the case number 3. So from case number 1, case number 2 and case number 3 clubbed together, I have always obtained the final result as tan inverse x plus y upon 1 minus xy is equal to tan inverse x plus tan inverse y, which is what we needed to prove. So again repeating that yes, the proof is not as important, but the formula you need to learn along with the condition that the formula exists only and only when xy is less than 1. In the next video, we will be seeing what happens when xy is not less than 1, what formula changes for tan inverse x plus tan inverse y. Formula you need to learn along with the condition that the formula exists only and only when xy is less than 1. In the next video, we'll be seeing what happens when xy is not less than 1, what formula changes for tan inverse x plus tan inverse y.